Okay, so hi guys. So in this lecture, we'll be seeing some more examples on the hydrolysis of alkynes. So let's get started with the first example for this lecture. So we have something like again alkyne, okay, and we are reacting it with HgSO4 and H2SO4 dilute. Okay, so what will be the product form? Product would be something like a ketone attached on the phenyl ring. Okay, so let's talk about the mechanism of this reaction. Okay, so mechanism is something like if we have this, okay, and Hg plus 2 would be attacked on by the alkyne and we'll get something like this product or intermediate, okay, plus 2 state. Okay, next what will happen is in presence of water molecule, the O will attack on the more partially positive carbon atom, which will be this one, and we'll get OH here, double bond, and at the same time the bond will be taken away back by the Hg to convert itself into Hg plus. Deduction of Hg took place here. Next what will happen is obviously we had something like this, okay, so positive charge on oxygen atom. Next what will happen is obviously it will take back its electron bond electron from the hydrogen atom, and as a result H plus would be created, okay, and we'll get something like pH C double bond COH, and at the same time Hg plus would be giving its electron to H plus, okay, to convert itself into Hg plus 2, okay, and we'll get something like this, which on tautomerism which will be converted into a keto group, okay, so this would be the product formed. Okay, so let's discuss another example wherein we have this alkyne, a cyclohexane, and we have alkyne substituted to the cyclohexane, and we have Hg plus 2 or HgSO4, and here we have D2SO4 now and D2O water. Okay, so what will be the product formed in this case is again we'll get something like CHD2. Okay, so let's see the mechanism. We have a cyclohexane and a substituted CH, which on reacting with Hg plus 2, again the alkyne group will actually form a bond with the Hg plus 2 and convert it into a double bond. Okay, the bond between itself and the neighboring carbon atom. Okay, next what will happen is Hg is in plus 2 state. Next what will happen is again D2O is the source of D2 is the water in this case. Okay, so H2O is replaced by D2O. This will again attack on this carbon atom and we'll get something like this as our product. O plus, I beg your pardon, this is D. Okay, and one more D, and side by side we'll have the breaking up of the bond between this carbon and Hg. As a result we'll get something like Hg plus. Okay, in the next step we'll have again H plus attacking on this D, which is getting removed because the oxygen will take back its bond pairs from the D. As a result we'll be getting something like OD here, double bond CH. Okay, negative charge on this carbon would be again be added by the, or you can actually say that this Hg would be getting removed and we'll get something like Hg would be getting removed here, okay, as a plus 2, thereby actually allowing this bond. Let me show it again. So what actually happened here is, we had originally 2D attached on oxygen atom, and as a result Hg plus will leave its bond with the carbon atom and will leave the space for D plus to get attached to the carbon atom. So as a result Hg in plus state here will be removed as a plus 2, and D would be actually coming from this oxygen atom and getting attached to this carbon atom, because the Hg paved the way for the addition of D here. Okay, next what will happen is, again we'll have acidic medium of D2SO4. okay, so in the acidic medium we'll have something like this will again form a double bond with this carbon atom. okay, and we'll get D plus released here. okay, which will again force back this bond to be directly taken up by this atom. okay, so I'm directly showing it rather than showing it here. So we'll get something like this as the final product, CH_D2. okay, so this is the final product formed. okay, so let's take another example. okay, we have something like this compound. again we pass it Hg in plus 2 state and H2SO4. so what will happen here is, again we get something like CH3. okay, so let's take another example of hydrolysis of alkyne. so we have something like this. okay, and we are again passing, not hydrolysis, hydration of alkene. okay, this is hydration only. so in presence of again HgOAc whole twice. okay, and water, and second reagent we are passing it a BF3 and THF, or rather we will be passing on NaBH4. okay, and T in basic medium. this is the first, and secondly we can pass, so we'll be passing a pH3 THF, and second time we'll be passing peroxide in again basic medium. so this is nothing but a OMDM, and this is nothing but HBO. okay, what happens in OMDM is addition of OH according to Markovnikov rule without rearrangement. okay, so which is more stable carbon atom here, or which will be more stable compound here? This would be Markovnikov product, and this would be anti-Markovnikov product. okay, so these two are position isomers, or rather positional isomers. okay, now let us take one more example before ending this lecture. so we have something like, so let's take this example, and we are passing it in HBO reagents. so what will happen is, obviously we know that the HBO is a syn addition. okay, so either this would be a compound formed, or we can have, rather I'll show the mirror image later on, we'll also have this compound formed as something like OH here, H here, and something like this. so obviously if you rotate it with 180 degree, what you will get will be a mirror image of this compound. okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing some more examples of OMDM, HBO, and then we'll be moving on to reduction reactions. okay, so till then, good luck and goodbye.